2020 Prentice Hall practice regions questions in the organic section. This is parts B, 2, and C. All right, so the first question says, draw the structural formula for this compound. All right, so what you have to start with is see how many carbons I have, and I have 1, 2, 3, 4 carbons. So I'm going to draw 1, 2, 3, 4 carbons. The 4 carbons must be connected by a minimal of single bonds. All right, so now I'm going to count out my hydrogens. So the first one I have 3 hydrogens, so I'm going to put 1, 2, 3 on that one. Second carbon has 2, 1, 2, it's saturated. The third carbon has 1, and the last carbon has 2, 1, 2. Well, if we look at all the carbons, do they all have 4 bonds? Well, the first one has 4 bonds, the second one has 4 bonds, the third and fourth do not, so therefore they can take another bond, and that's going to go between the 2 carbons. So we have an alkene. So there 31 says draw the structural formula for it. There it is. 32 says state the IUPAC name for this compound. All right, you have 4 carbons. So 4 carbons is going to use the prefix of bute. And then the fact that it's got a double bond in it means it's going to have an ene, and it's going to be on the first carbon. So it's going to be bute 1-ene or 1-butene. Either way is acceptable. Bute 1-ene or 1-butene. Some people say, wait, why is it not on the third carbon? Well, it's not really the third carbon because we got to start counting from the shortest end, which is on the right side. 33 represents a product formed when HCl reacts with this. So we're putting in a HCl across that bond. All right? And so what happens to that? Well, that's an addition reaction because we have an unsaturated hydrocarbon. The IUPAC name for this compound, again, is going to have 4 carbons. All right, because we have 1, 2, 3, 4. It's going to be bute. And now it's all saturated, so it's going to be butane, all single bonds. And then we have the chlorine here. We have this chlorine on the second carbon, so we're going to call that 2-chlorobutane. The 2 tells you on the second carbon something's happening, and then right after it says it's a chloro. On the second carbon, there's a chlorine. 34 says in question 33, what type of organic reaction takes place to produce that? Well, we said we're taking an alkene. We're going to add a hydrogen chloride across that double bond, and that is a unsaturated hydrocarbon being added, so that is an addition reaction. Remember, the vowels go together. Unsaturated has addition, saturated has substitutions. 35 says which typical chemical reaction is represented by that equation. So again, we have a C4H8. C4H8, all right? The number of hydrogens is twice the number of carbons. That means it's an alkene. We have a halogen being added to an alkene, producing one product. That is an addition reaction. Alkenes are unsaturated. That is an addition reaction. Draw the structural formula of the product 1,2-dichlorobutane. That's going to be this thing here, 4 carbons. So we're going to do 1, 2, 3, 4. All right. It says 1,2-dichlorobutane. So it's all single bonds, but we're going to have the chlorine added on the first and second carbon. So we're going to have a chlorine there and the chlorine there. That is 1,2-dichlorobutane. We could just as easily put those chlorines down there, okay? We could just as easily put those chlorines up top. I don't know why I ungrouped them. Always does that. You know when I don't want it to ungroup. We could just as easily put those chlorines up top here, or we could put those chlorines over there. Or you could put a chlorine, you could separate it and put a chlorine out front and on the second. But either way, that's 1,2-dichlorobutane. Identify the homologous series of hydrocarbons to which the organic reactant, belongs. This reactant, the number of hydrogens is twice the number of carbons because the number is 4. We have H8, which is twice 4, so that is your alkene, A-L-K-E-N-E. 38 says identify the type of reaction. We have a C4H10. C4H10, that means the number of hydrogens is twice the number of carbons plus 2. So this is an alkane. This is an alkane having something. It is saturated. Saturated reactions saturated hydrocarbons can undergo substitution reactions only. And this is draw the structural formula for the organic product. The organic product. This is the inorganic product. This one here, C4H9Cl, is the organic product. So we're going to do 4 carbons in a row. 1, 2, 3, 4. We're going to have 9 hydrogens, and we're going to have a chlorine on there. So we're going to 1, 2, 3. All right. We're going to put a chlorine on there somewhere. It doesn't really say where. It just says there's a chlorine somewhere. We can put that chlorine anywhere. We can put that chlorine there. We can put that chlorine on the second carbon. We can put it up here. We can put it over there. We can put it up here. Doesn't matter. We just have to have a chlorine on there somewhere. This one here says esters have distinctive odors. All right. And this says methylbutanoate has an odor similar to pineapple. Ethyl methanoate has an odor similar to raspberries. Draw the structural formula for the ester that has the odor similar to pineapple. Pineapple one, that one is the methyl butanoate has an odor similar to pineapple. All right, so we want to draw methyl butanoate. The methyl part is a single carbon. All right. It is attached to the butanoate. The butanoate is where you have the single bonded oxygen, a carbon with a double bonded oxygen, the carbonyl group, and then you have 3 other carbons because it's butane. So there's 1, 2, 3, 4 carbons. They all have hydrogens saturating them. And so our methyl butanoate, its structural formula is that right there. 41 says, what's the chemical name for the alcohol? All right, was the chemical name? Hang on, thinking here. What's the chemical name for the alcohol that reacts with methanoic acid to produce the ester that's similar to raspberry? Ethyl methanoate is raspberry. So we want to know what's the name of the alcohol that reacts with methanoic acid. And so that has to do with the ethyl portion here. All right, this ethyl portion, ethyl comes from the alcohol. So therefore, it's going to be ethyl alcohol or ethanol. (42 through 46) says it's incomplete. All right. Circle only the acid functional group. It says an incomplete reaction represents esterification. The alcohol is represented by the X. So whatever this is here in the alcohol is the X. Circle only the acid functional group. The acid functional group is going to be on the one reactant. There's your acid functional group. 43 says write the IUPAC name for the reactant represented by its structural formula in this equation. So they're asking, what is this? What is that? Well, it has 2 carbons on it, and it has an acid on it, so that one's going to be ethanoic acid. All right, ethanoic acid is going to be this portion right here. All right, that is the ethanoic acid portion. The whole other portion here, the CCC, is represented by the alcohol. And so 44 says draw the structural formula for the alcohol represented in this equation. The alcohol must have had 3 carbons. So it had 1, 2, 3 carbons. Those ends are saturated, and you had the OH here. All right, the OH, which is the O right here. All right. And so there, that part was the alcohol. So it was 3-carbon alcohol. Number 45 says state the name of the alcohol represented by this. That is going to be a propanol, and more specifically, the alcohol is on the first carbon, so it's going to be 1-propanol, or propan-1-ol. 46 says name the organic product of this reaction. All right, remember the alcohol portion, this portion over here, the alcohol portion, is going to get the substituent name, the YL portion. All right, this first part is going to get the NO8 portion. So this is going to end in NO8. All right, so you're going to have 3 carbons, which are going to be propyl, P-R-O-P-Y-L, propyl, because that comes from the alcohol part. The acid part has 2 carbons in it, so it's going to be an FNO8. So our ester that was created is going to be called propyl ethanoate. (47) and 48 have to do with those 2 hydrocarbons there. It says they are isomers of each other. They are isomers of each other means they have the same number of carbons, same number of hydrogens. They have the same number of hydrogens. They are hydrocarbons. Okay? Explain, 47, in terms of bonds, why these hydrocarbons are unsaturated. Unsaturated have to do with alkenes and alkynes. Both of these hydrocarbons, 1 and 2, have double or triple bonds, multiple bonds, and therefore they will be unsaturated hydrocarbons. 48 says explain in terms of structural formulas and molecular formulas why these 2 hydrocarbons are isomers of each other. They're isomers because they both have the same molecular formula, C5H8, but they are put together differently, therefore they have different structural formulas. Different structural formula, same molecular formula, that is the definition of an isomer. 49 through 51 says in industrial organic reaction, C3H6, which is an alkene, reacts with water in the presence of a catalyst. We end up making that compound. In terms of bonding, why is C3H6 classified as unsaturated? Because it has a double bond in it. In terms of bonding, remember, not saying you can say, yeah, it could hold more hydrogens, but in terms of bonding, it has a double bond in it. 50 says write the IUPAC name for the organic reactant. The organic reactant is the first part here. This is the organic reactant. It has 3 carbons in it, so it's going to be a prop. It has a double bond in it, so it's going to be an ene. So that organic reactant is called propene. And 51 says identify the class of organic compounds to which the product belongs. Because it has this OH right here, it falls into the class of an alcohol. Alcohols have the OH. And that's it. Boom, we're done.